Okay, but yesterday we studied about the ionic bond.
Yeah.
So, can you define the ionic bond?
Can I define what?
Ionic bond.
Um, Ionic bonds are like the strong, like electrostatic forces of attraction between a metal and a non-metal, between like the atoms in a metal and a non-metal.
Okay, so which compound are formed?
Ionic compounds.
Ionic compound. Can you give me the example of ionic bond? Ionic compound?
Sodium chloride.
Sodium chloride. What is the melting point of sodium chloride?
I'm not sure, I forgot.
801 degree centigrade.
Okay.
Okay. So today's our topic for chemistry is covalent bond. Okay.
Okay.
Actually, covalent bond is only formed in non-metals. Can you give me the name of any non-metal?
Um, Hydrogen.
Okay, I'm providing you the periodic table. Why it is not visible here? Okay, so this is the hydrogen of periodic table and this is the helium. And the first is a series of the period is Lebbeeb-Kunafne. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. We can revise it Lebbeeb-Kunafne. And second is the Namag, Al-C, Pascalar. Mona, what is your grade in which you are studying?
10.
10?
Yeah,
Okay, and your is Cambridge or GCSE?
GCSE.
GCSE. Okay. So you are saying that li- except hydrogen, lithium, sodium, beryllium, magnesium, these are the metals. Okay.
Okay.
If you move into the left of the in the right of the periodic table from nitrogen, phosphorus, from carbon is also these are non-metals. So except hydrogen, these are the metals, and hydrogen is a non-metal, and these remaining elements from here from hydrogen, carbon, silicon. So these are non-metals. Okay.
Okay.
So covalent bond is only present in non-metals. If we see the definition of the covalent bond, it is formed by mutual sharing of electron. Mutual sharing of electron. Do you know the atomic number of elements?
Some of them, yeah.
So each element has atomic number. According to the atomic number, we can decide the number of electron and proton present in an atom. So the bonding is depends upon the number of electron present in the valence shell. Okay.
Okay.
So if I see here atomic number of hydrogen is 1 and helium is 2 and lithium is 3 and beryllium is 4, boron is 5, carbon is 6. Because this periodic table is arranged according to the increase of their atomic number.
Okay.
So atomic number of nitrogen is 7, atomic number of oxygen is 8, and atomic number of fluorine is 9, and atomic number of neon is 10. And likewise, atomic number of sodium is 11, 12, 13, 14, 15, 16, 17, 18 up to. So atom form bond only to become stable like these elements. These are called noble gases. Okay?
Okay.
Because their valence shell are completed. So they are inert. They cannot form an bond with any atom because they are stable. They don't need to gain and lose the electron to become stable because these are already stable. So remaining these elements want to become stable like these noble gases. Okay.
Okay.
So when we see the covalent bond, this covalent bond is only present in non-metal and it is formed by the mutual sharing of electron. So every bond is formed only by presence of electron present in the valence shell.
Okay.
Do you know valence shell?
Yeah.
How you will define the valence shell?
The outer shell of an atom.
Okay. So if we see the example like hydrogen, H2, Is hydrogen is a non-metal?
Yeah.
So it's mean covalent bond is present in the H2. Okay.
Okay.
Now we check how covalent bond is present in H2, and we shall explore with the help of example. And this is the one hydrogen atom, and this is the second. So atomic number of hydrogen is 1, and this hydrogen will be 1. When atomic number is 1, so it means there will be 1 electron. So hydrogen has 1 electron in the valence shell. So it can form 1 bond. Number of bonds depends upon the number of electrons present in the valence shell or required in the valence shell. So in hydrogen there is 1 electron. I am representing its 1 electron with a dot, and electron present in this atom I am representing with it cross. So this is called dot and cross. So one
Okay.
electron from this hydrogen and one electron from this hydrogen, they share with each other. When they share with each other, then two electrons are accumulated. These two electrons make one bond. So this bond represent mutual sharing of electrons. So this is called covalent bond. So you are seeing there are two electrons needed to make one bond. One electron comes from this hydrogen and one electron comes from this hydrogen. So these two electrons participate to make one bond. Okay.
Okay.
So in hydrogen, single covalent bond is present. Okay.
Okay.
So there are three types of covalent bond: single bond, double bond, and triple bond. So when there is one bond, it's mean we are talking about single covalent bond. How you will define the single covalent bond?
I'm not sure. So, like, when is it when only like one electron is shared?
And this the covalent bond, which is found with the sharing of one electron. One electron
Yeah.
from
Okay.
this atom, one electron from this atom. Okay.
Yeah.
So we can explore more example about single covalent bond, like HCl. Another example like HCl. Hydrogen is also non-metal. You are seeing here, and chlorine is also non-metal. So covalent bond is always present in the non-metal. So we see how single covalent bond is present in HCl. You know, atomic number of hydrogen is 1.
Yeah.
So there will be 1 electron in the valence shell. And atomic number of chlorine is 17. Okay.
Okay.
So it's a first shell where there will be 2 electron, and second shell there will be 8 electron, and third shell there will be 7 electron. Okay.
Yeah.
So hydrogen has 1 electron. It needs only 1 electron to become stable. Because when an atom gains 2 electron in the valence shell, it also becomes stable because it completes duplet rule. Duplet rule also follows the stability, also follows the stable for the atom. So chlorine has 7 electron in the valence shell. So it needs 1 electron to become stable. So when it needs one electron to become stable, so it means chlorine can form one bond. Okay.
Okay.
So only in bonding you will write only electron of the valence shell, because valence shell electron only participate in the formation of any type of bond.
Okay.
So we see, like if we see the example, there is one electron in hydrogen. I am representing the electron of hydrogen with cross because there is one electron. And, and you must write the electron of the valence shell. If we see in chlorine, there are 7 electrons in the valence shell. Okay. Then
Okay.
you put these electrons like dot 1, 2, 3, 4, 5, 6, and you will put one here to become, because it need one electron to become stable. When it gains this cross electron from hydrogen, it completes its 8 electron for a short time. For a short time, hydrogen accepts this electron from chlorine. It gains 2 electron and it becomes stable. So they try to become stable with each other. This is called mutual sharing. They share with each other like a mutual. Okay.
Okay.
So if we see the hydrogen electron, this this mutual sharing with the chlorine, and you must write the electron of the chlorine in the form of dot. There are 7 electrons in the valence shell, and 1 electron need to become stable. When it gets 1 electron from hydrogen, it becomes stable. When hydrogen get 1 electron from the chlorine of this, it becomes stable. So this bond is represented as this HCl. So single bond is formed because 2 electrons are participated. When 2 electrons are participated, so one bond is formed. That is called single covalent bond. Okay.
Okay.
You can explain more and more example, like if I told you like CH4. A CH4 example is given in your book.
Yes.
Methane. Okay. CH4 is also known as a methane. You see, atomic number of carbon is 6. This. Okay.
Okay.
So if you write their atomic number, like carbon atomic number is 6, and hydrogen, atomic number is 1. You see, if there is a one in first shell, there will be 2 electron of carbon, and second shell there will be 4 electron. So there are 4 electron in the valence shell. It means carbon is not stable. Either it need to remove 4 electron, then it will get 2 electron in the valence shell, that is stable. Either it gains 4 electron from other atom and it's complete its 8 electron in the valence shell. When it gains 8 electron in the valence shell, it becomes stable. So it can complete its stability like 2 ways. Either it need to remove 4 electron, either it need to get more 4 electron to become 8. Okay. It's
Okay.
mean it's mean carbon can form 4 bond. Like this, we check this. You have to write electron of carbon 4 in the valence shell. You write this in highlighted form. And there are 4 hydrogen. You need to write electron of hydrogen with cross. Then this mutual sharing with this, and it mutual share with this, and it mutual share with this. Then likewise, single four bond are formed because carbon can form four bond because it has four electrons in the valence shell. Number of bond depends upon the number of electrons present in the valence shell. So there are single electrons. So it is also example of single covalent bond. Is it clear?
Yeah.
Okay, we check the another example like if I say mm, you make the bond of single. Okay, we example are given. We move to the double covalent bond. Okay.
Okay.
Double covalent bond. How you will define double covalent bond? It requires
Double covalent. Is
two
it?
electron are involved in the mutual sharing
Yeah.
of electron from each atom. Okay,
Okay.
two electron are needed to become two covalent bond. So we see example of O2, oxygen. Do you know about oxygen?
Yeah.
We breathe in oxygen for metabolism of glucose for producing energy. Actually, this oxygen is released during photosynthesis process. Okay.
Okay.
So now we check the covalent bond and O2. You know atomic number of oxygen is 8.
Yeah.
So how many electron will be in the valence shell of oxygen? And first shell there will be 2 electron, and second shell there will be 6 electron. Okay.
Yeah.
So it's mean oxygen needs 2 electron to complete its 8 electron in the valence shell. It needs 2 electron. When it needs 2 electron to become stable, it means oxygen can form 2 bond. Okay. So
Okay.
now you have to write the electron of oxygen. You write one oxygen atom with dot. You need to write 6 electron. And with the other oxygen, you write their electron with a cross. There are 6 electron in the valence shell. You always write only electron of the valence shell here. Okay. So
Yeah.
this electron mutual share with this, and this electron mutual share with this. So likewise, 2 covalent bond are formed because oxygen needs 2 electron to become stable. And there are 2 electron are present on these and these, and you have to write their electron like cross. Okay. So you are seeing here these electron which are involved in the bonding. These are called bonding electron. The electron that form bond, these are called bonding electron. And the valence electron that do not involve in the formation of any bond, these are called non-bonded electron. These non-bonded electron also called lone pair. Have you heard about lone pair?
No.
The valence electron that are not involved in the formation of any bond. They must be the electron in the valence shell, but they do not take part in the formation of any bond. These are called lone pair. So when oxygen form bond, it has two lone pair. One this pair, one this pair. Each oxygen atom has two lone pair. This oxygen atom has two lone pair. Is it clear?
Yeah.
It's mean when oxygen form any type of bond, it must have two lone pair on oxygen atom. So this is example of oxygen of the double covalent bond, two bond are formed, that is called double covalent bond. Now we check the example like ethene, CH2, CH2. This is called ethene. This is the organic compound. This is the hydrocarbon. We check how double covalent bond are present in the ethene. You see here, this is the carbon
Yeah.
and this is the carbon. So how many electrons are present in the valence shell of carbon? 4. And you write the electron of okay, it needs to make two bond. Then you will write two electron here. Because it has two electron, 4 electron in the valence shell. You will write two electron together because it forms two bond, and you will write one electron here, one here. And you can write two electron of this carbon like here and two electron separately. So there are two hydrogen. You will write hydrogen one here and one here. And you write the hydrogen of this here and you write the hydrogen of this. Now you represent the electron of hydrogen with cross because one electron present in the hydrogen because it's atomic number 1. And here's cross, then you will put here dot. So you must write different. When there is cross, it should be dot. When you put it dot, it should be cross. So this mutual sharing take place with this, and this mutual sharing take place with this. This mutual sharing will take place this, and this mutual sharing will take place this. And this mutual sharing with this, and this mutual sharing with this. So two covalent bond are formed in the ethene. In ethene, there is one double covalent bond. If I ask you how many total covalent bond are present in the ethene, can you count it?
What did you say?
I asked you total number of covalent bonds present in the ethene. You count 1, 2, 3, 4, 5, 6. So there are 6 covalent bond present in the ethene molecule. Okay? Got this point?
Yeah.
Okay. If I ask you how many double covalent bond are present in the ethene? How many double covalent bond are present in the ethene?
One.
One. Good. So such type of question can come in your exam. If I ask you how many number of covalent bond are present in the methane CH4?
4.
Four. So it means that it is easy to count these bond. It depends upon the when you know the firstly atomic number of elements. When you know the atomic number, it means you can find their electron. When you can find their electron, you can guess the number of electron present in the valence shell. Then you can decide how many electron are required to remove or need for making bond. Okay.
Okay.
So this is example of the double covalent bond. Now we check the example of triple covalent bond. Triple covalent bond. How you will define the triple covalent bond?
Is it
It's
when
mean
3 electrons are
three
shared?
electron from each atom will take part in the formation of bond. Okay.
Okay.
So if we take the example like N2, this is called nitrogen gas. Okay.
Okay.
Now we check the bonding in N2. Is there a triple covalent bond present or not? Atomic number of nitrogen is 7. You know.
Yeah.
So what number of electron are present in the valence shell of nitrogen?
5.
5. It's mean its first shell has 2 electron and second shell has 5 electron. So 5 electron are present in the valence shell of nitrogen atom. So how many electron are required in nitrogen atom to become stable? How many electron are required in the valence shell to become stable?
3.
3. Because it is 5 electron, it need more 3 to become 8. That's why nitrogen can form 3 covalent bond because it requires 3 electron. Okay.
Okay.
Now we check the covalent bond in nitrogen. Firstly, you need to write the electron of nitrogen. There are 5 electrons in the valence shell. Because it forms 3 bond, you will write 3 electron with the cross and 2 electron right here. So you need to put 5 electron in the nitrogen. You always put valence electron. And second nitrogen atom, it will have 5 electron in the valence shell. You need to put these 5 electron like this. So this mutual share with this electron, this cross mutual share with this, and this cross mutual share with this electron. So it's mean 3 covalent bond are formed in nitrogen atom. Is it clear?
Yeah.
If I ask you how many number of lone pair are present on one nitrogen atom?
What did you say?
Number of lone pair on one nitrogen atom.
Two.
Lone pair. How you will define the lone pair? Again, listen. The number of valence electron that do not take part in the formation of bond, that are called
Two.
lone pair. Okay. So this is one lone pair, and this is another lone pair. So one lone pair is present on each nitrogen. So on each nitrogen, one lone pair is present. Okay.
Okay.
If I ask you number of lone pair present on oxygen, there were two lone pair, one this pair, one this pair. Okay. On each oxygen atom, there are two lone pair. But on nitrogen atom, there is one lone pair. Is it clear?
Yeah.
So we have to check an example like ethine. This is called ethine. And triple covalent bond is present in ethine. Can you make their burning?
Can I make what?
Yes, you have to draw their covalent bond.
No. What is HC?
This is the carbon. And this is the carbon. So number of electron present in the valence shell of carbon, 4. Okay.
Okay.
So you need to write like, because it forms 3 covalent bond, you will write 3 electron here because there are 4 electron in the valence shell. And you write 1 electron here. Okay.
Okay.
So with of this carbon, you will write 3 electron with the cross and 1 electron like this. So there is 1 hydrogen atom. You write with this cross and you write with, okay.
Okay.
So 3 electron are involved in the formation of covalent bond. And this electron pair share with this, and this electron pair share with this, and this electron pair share with this. So 3 covalent bond are formed. Then you can write like this. Can you count the number of covalent bond in ethine?
1, 2, 3, 4, 5.
5. So how many number of triple covalent bond are present in ethine?
1.
1. Can you tell me the number of electron that are involved in the formation of bonding?
two, three, 8, 9, 10.
10. It's mean two electrons are needed to make one bond. So there are 10 electrons. It's mean it must be need to make 5 bond. Okay.
Okay.
So this is the example of triple covalent bond. No, I'm giving you the 3 example to elaborate and decide it belong to which category of covalent bond, single, triple, double. Okay.
Okay.
So first example I'm assigning you like water, H2O. Can you guess the bonding in the water? Which type of covalent bond is present in water? Single, double, or triple?
Is it like uh is it
You don't to like this. You must draw their structure. Then you would decide the number of bond, and you can decide which type of covalent bond is present in water. So you see there, and there is one oxygen. Okay.
yeah,
So number of valence electron present on oxygen are 6. Do you know?
yeah,
So you have to write there 6 electron present in the valence shell. You write either cross 6 electron. So there are 2 hydrogen atom. So you know there is 1 electron in the valence shell of hydrogen atom. Then you put a cross here, then you will put dotted. Then you represent the dot electron. Okay.
yeah,
Then it shares this mutual sharing of electron with this, and this electron share with this electron. So one single covalent bond is formed in this line, and one single covalent bond is formed in this line. When they share, this structure is become like this. Then these 2 electrons you must place because these are called lone pair. How many lone pair are present on the oxygen atom in the water molecule? How many lone pair are present on oxygen atom in water molecule?
2.
2. Because these are the valence electron and they didn't take part in the formation of bond. That's why these are called lone pairs. So in each molecule where oxygen will make bond, there will be present only 2 lone pair. Is it clear?
Yeah.
So can you guess which type of covalent bond is present in the water molecule? Single, triple, or double?
Single.
Single. Because one electron participated in the formation of bonding. That's why single covalent bond is present in the water molecule. So can you guess how many number of covalent bond are present in the water molecule?
2.
So can you tell me the number of bonding electron present in the water molecule? Bonding electron. They
4.
involve in the formation of bond.
Is it 4?
How many?
4.
4. Okay. So I'm assigning you another example then to decide which type of bonding is present. I'm assigning you CO2. Carbon dioxide. Can you guess which type of covalent bond is present in CO2?
Uh,
Can you draw the covalent bond?
I don't know. I think so.
Can you see the where carbon is present in the periodic table? In
Yeah.
non-metal side. Okay.
Okay.
That's mean covalent bond is possible in carbon dioxide because carbon dioxide is a non-metal.
Okay.
So if we can check covalent bond in CO2 through their formation of bonds. Central atom is carbon. How many valence electron are present in the carbon atom?
Cool.
4. You can write their electron as a cross. So there are two oxygen. You will write one oxygen in right side and one oxygen in the left side. Number of electron present in the valence shell of oxygen atom. Can you
What did
tell?
you say? What?
Number of electron present in the valence shell of oxygen atom.
6.
6. Because its atomic number 8 is 8, it needs 2 electron to become stable. Okay.
Okay.
So you need to put there 6 electron. And likewise, this mutual share with this electron will share with this. Okay.
Okay.
So this structure will be like a double covalent bond. Is it clear?
Yeah.
Can you easily guess which type of bonding is present in CO2?
Double bond.
Double bond. How many lone pair are present on the oxygen atom?
2.
2. Now all the concept are clear about the formation of covalent bond?
Yeah.
Any type of difficulty?
No.
Would you draw all these bonding on your notebook in your home?
Yeah.
Okay, good. Tomorrow I will check when you draw on your notebook and you have to send the picture of that. Okay.
Okay.
So now we explain the types of covalent bond.
What did you say?
Sorry, there are another classification of the covalent bond that is called types of covalent bond.
Okay.
We can say there are two types of covalent bond. One is polar and second is non-polar. This picture is visible to you.
Yeah.
One type is the polar covalent bond. Polar covalent bond is found between two different atoms. First, first, talk about the polar covalent bond. It is found between two different atoms. One atom will be more electronegative. The element, the atom that is more electronegative, it will share electron towards itself. When there is electronegative difference between two atoms is 0.4 to 1.7. So there will be the polar covalent bond. Likewise, the example like H2O. H2O is formed, there is a hydrogen and oxygen. So hydrogen and oxygen are two different atoms. When there are two different atoms, must be there must be electronegative difference between atoms. So these molecules will be considered as a polar covalent bond, polar covalent compound. They must have polar covalent bond. Is it clear?
Yeah.
Now check the HCl. H and Cl, hydrogen and chlorine. These are the two different atoms. So when bonding is present between two different atoms, that is called polar covalent bond. Is it clear?
Yeah.
Because hydrogen has a one electron, chlorine has seven electron, and one electron is formed between two atoms. This is called polar covalent bond. Second type is non-polar covalent bond. Non-polar covalent bond is formed between two similar atoms like O2, CH4. The CH4 we can say their electronegative difference is zero. Another example for non-covalent covalent bond is H2. H2 is formed between two similar atoms. Okay?
Yeah.
And O2 is formed between two similar atoms. We can say they are a double covalent bond, but it is non-polar because this type of bonding is present between two similar atoms. A covalent bond where electrons are shared equally. They have similar electronegativity. Both have same electronegative difference. Their electronegative difference must be less than 0.4. In H2, there will be electronegativity difference 0 because electronegativity of hydrogen is 1 and electronegativity of hydrogen 1. 1 minus 1, there will be 0. Electronegative difference of oxygen is 0.8, 0.8, they cancel out, so their difference will be 0. So in non-polar, in a simple way, it is found between two similar atoms. When it is found between two similar atoms, so there will be no electronegative difference. Is it clear?
Yeah.
Okay, do you have any question or query about this after the lecture?
No.
Okay, tomorrow we will discuss next topic in your class. Okay?
Okay.
Okay, better take care. Thank you.
Thank you.